This is the third and final section of the inequalities chapter. And here we're going to be looking at solving inequalities where it involves a modulus. Now in Pure 2, and I'll put a link at the bottom, we would have solved modulus equations. So where you've got something equal to something else. So we may, for example, have solved something like this. The modulus x squared plus 3 equals x, this type of thing. So the only difference now in further Pure 1 is that we are going to be looking at inequalities. Now, just like before, if you have something like this, one function greater than another, you're looking for the parts of the graph where f of x is above g of x in your sketch, so you still need to sketch them. And if you have something like where f of x is greater than f of x, then we're looking for the part of the graph where g of x is above f of x. So just a quick reminder about sketching modulus equations. Now there are two types, one where you have the modulus around the whole thing, and one where you have just the modulus around x. When you have modulus around the whole thing, you sketch the original graph. So let's draw something like this. Now what I'm going to do, I'll just put the bit below the axis as a dotted line like this. And in the bit below the axis, we flip up like this, reflect. So we reflect any part of the graph below the axis to above the axis and above the x-axis. Okay, so that's how we deal with that. If we've got, however, the modulus sign is around the x, so if I were to draw the original graph of this, let's say I've got something like this, and let's say that went down like that, then I take the part of the graph that's on the positive x side and I reflect it on the negative x side. Okay, so here we reflect any let's spell reflect properly, reflect any part of the graph in the positive x to the negative x. So the bit that's on the negative x that was there originally, you just basically rub that out. Okay, so with all of these we're going to solve graphically. So I'm going to do a sketch of first of all the modulus of that quadratic. So if I'm going to do that, I need to know what its roots are. So we'll do x squared minus 4x equals 0. That factorizes x minus 4, and that gives the roots of the quadratic as 0 and 4. So we'll put those in. So that's going to cross here and here. So obviously it's like a U-shaped one, so we'll just put a U in there. Now the bit below the axis, I'm just going to do dotted. Because the modulus is around the whole thing, that bit that gets reflected is going to be up there. Okay, and I'll just take the dotted bit out here. Right, okay, the next one we've got is the line x equals, or y equals 3. So y equals 3. Now, if I draw that on, and I'll do that in purple, does that y equals 3, does it go here? Is that where it goes? Or does it go further down? Does it actually intersect through here? And that's 3. Well, the only way we're going to know is by working out how high this goes, and we can get that by working out how low the original one went. So there are lots of different ways we could do it. We could complete the square. I'm just going to differentiate to find the minimum of x squared minus 4x. I'm going to find the minimum. It looks like minimum. I'm having real trouble writing minimum. Minimum of y equals x squared minus 4x. So if I use differentiation, dy dx equals 2x minus 4. So at the minimum, dy dx equals 0. So at min, dy dx equals 0. So you get 2x minus 4 equals 0, which gives you x equals 2. So that minimum is at an x coordinate of 2. We want to know the y coordinate. So to find the y coordinate, all we're going to do is substitute x equals 2 into the original equation. So that will be y equals 2 squared minus 4 times 2. So that will give a y coordinate of 4 minus 8, so minus 4. Now if the minimum is minus 4 and it's got flipped up, it means the top part here goes up to 4. Which means now when I draw the graph of y equals 3, it's going to be below that point. So that gives these 4 points here. Okay, actually let me do them in different colors, those points, because the way we work them out is going to be different depending on whether it's on the original part or the reflected part. So I'm going to put the ones which are on the original part of the graph in green, and the ones which are on the reflected part of the graph I'm going to do in red. So let's start with the green ones. The green points are on the original part of the graph. Now to solve the modulus, when it's the original part of the graph, you replace the modulus sign with brackets and a plus sign, and we solve that equal to 3. So that gives me x squared minus 4x minus 3 equals 0. Now that doesn't factorize because we can't have 3 and 1, because that's not going to give me 4. So I'm either going to use the quadratic equation or I will complete the square. I think completing the square is easier. So I'll have x squared, or x minus 2 all squared. Okay, so and minus 3. Now what adjustment do I need to make? This is going to give me plus 4, so I need to minus 3. So I've got x minus 2 all squared is 7. So x equals square root both sides, so it's going to be 2 plus or minus root 7. So those are those crossing points. So this is x coordinate is going to be x equals 2 minus root 7. And this other green point here, this is going to be x equals 2 plus root 7. Okay, let's now do the red points. Now the red points, this is where the graph, the blue graph, the modulus graph, it's the reflected. And whenever you do the reflected, you replace the modulus sign with brackets and a minus, and we solve that. Right, so this will give me minus x squared plus 4x minus 3 equals 0. So that'll be easier if we have x squared minus 4x plus 3 equals 0. Now this one does factorise, doesn't it? So x is going to be 3 and 1 minus 3, x minus 1. So this crosses at x equals 3, x equals 1. So these green points, one is 3 and one is 1. So this, or red points, this point here, x is 1. This point here, x is 3. Now we need to solve when the modulus graph is below 3. When is the modulus graph below 3? Let's highlight that. It's below the modulus graph here and here. So now we can write our answers as these inequalities. So between these two values, so this and this, and between these two values here. So that's going to be when x is between 1 and 2 minus root 7. And it's also going to be when x is between 3 and 2 plus root 7. Okay, so we've got another modulus one here. Now sometimes you need to rearrange before you sketch, which is what we need to do here, which is take away x from both sides. So actually we want the modulus of 3x graph and 2 minus x graph. Right, so let's plot these. So x here, y here. So we'll draw y equals 3x. So maybe something like this. Now, because the modulus sign is around the whole thing here, it means we take this bit that's below the axis and reflect it up. So we'll end up with something like this. That's V shape, like this. And then we want to draw the graph of y equals 2 minus x. So let's just label this one first. Y equals modulus 3x. Now, the other line we're going to draw is basically y equals negative x plus 2. Now, this graph is less steep than this one. This graph is going to cross at 2 and 2 here. You can easily work those out by making x equal to 0, y equal to 0. And because it's less steep, we need to ensure that it crosses in 2 places. Yeah, that's really important because if you're not careful and you don't get the steepnesses right, you may not get them crossing in the right number of places. So we have to work out what these 2 points are here. We want to find out when the 3x graph is below the 2 minus x graph. So we need to work out these coordinates here so we can then give this inequality. So we want to work out what these coordinates are here. It's going to be between those. So first equation we're going to solve to find this point here. Because it's on the reflective part of the graph, we replace the modulus with brackets and a minus sign, and we want to solve that equal to 2 minus x. So minus 3x equals 2 minus x. So if we add x to both sides, we'll get negative 2x equals 2, which means x equals negative 1. So that's this coordinate here. Now for this point here, this is not on the reflected part of the graph. So you can put brackets and a plus sign. It's not really necessary, just take the modulus away because it's the original part of the graph. Is 2 minus x. So 3x equals 2 minus x. Let's add x to both sides. So you've got 4x equals 2. So this time we get x equals, and we need to be careful, it's tempting to put 2, x equals a half. So now we can write our inequality that x is less than or equal to a half. Now it's less than or equal to because that's what's in the original question up here, less than or equal to. And it's greater than or equal to -1. So that's our final solution for this one. Okay, so here we can see that we've got a modulus graph to sketch and a straight line. The only difference with this one is we're going to leave our answer in set notation. So we'll start with our sketch like this. Now, if I'm doing y equals x squared minus 19, it means that I'm going to have roots at plus or minus root 19. So we'll draw the graph here. Now I'll do the reflected one straight off. I won't draw the original bit. So it's going to look something like that, probably a bit more curved on the other side. So maybe we'll try that again. So like this, and it's going to be symmetrical about the y-axis. So we have root 19 here and negative root 19 here. Then we've got our straight line, so we want to draw our y equals, we'll just expand the brackets, 5x minus 5. So that's going to cross the axis at -5 here. And this line is going to intersect at 2 points. It's actually going to do this. Yeah, now how do I know it's going to do that? Well, I can always check. If I work out this coordinate here, that is where y equals 0. So if I've got 0 equals 5x minus 5, 5x equals 5, x equals 1, and 1 is less than root 19. So it has to cross at that point. So I need to find these points of intersection here. And I want to find the points where the modulus graph is below the line. So I need to work out what this interval is here, and I'll work out that interval by solving simultaneously. So let's start with the first green point, the one furthest to the left, and that is on the reflected part of the modulus graph, or the original graph. So I'll replace it with brackets and a minus sign, equal to 5x minus 5. So I've got negative x squared plus 19 equals 5x minus 5. So we'll write that as x squared. So we'll add x squared to both sides, plus 5x. And then we'll take away 19 from both sides. So we'll have minus 24 equals 0. Now I think that factorizes 8 and 3. So plus 8 minus 3. So this means that the where it crosses the modulus graph, now I get two values. I get -8 and I get x equals 3. Now only one of these is right, and the reason I've got two solutions is because basically I've looked at this quadratic here. By making it a minus, I've like reflected the quadratic and say, right, where does this quadratic cross? Now it does cross again down here. Yeah, that straight line will go down there and give me this upside down quadratic. But obviously I've only got that bit of the upside down quadratic. So it can't be the -8 because that'll be where it crosses down here somewhere. It's got to be the plus 3. So I'll cross the -8 out and just put a box around the 3. Now the other point where they intersect, it's not on the reflected part of the original graph. So brackets and plus sign this time. As I said, I don't really need them, but just for consistency so you can see what I'm doing, equals 5x minus 5. So that gives me x squared minus 19 minus 5x minus 5 equals 0. Sorry, that should be plus 5. So that gives me x squared minus 5x and minus 14 equals 0. Now, does this factorise? I think it does, 2 and 7. So, will that work? Yeah, minus 7, negative 7 plus 2. So, again, I get solutions, or we'll get two solutions, x equals 7, x equals negative 2. Now, again, only one of these is right, and it's got to be the plus 7, because what I've done, I've solved the whole of the original quadratic, and it would cross again down here, and that would give me the minus 2. Yeah, so again, we need to look at what's actually going on and decide which of the solutions do we discard, because we haven't got the whole of the quadratic there. So all I need to do now is write down my answer. Now I need to write it in set notation. So remember, we do you try and do curly brackets if you're any good at curly brackets, ideally. We'll do square brackets, so x and then colon, and then next to that we write the inequality. Now it's between 3 and 7, isn't it? And the original says less than or equal to. So 3 and 7 like this. So this would be our answer in set notation. As I said, if you're any good at drawing curly brackets, you can do that instead, but I don't think you're going to lose marks if you put square brackets in instead of curly ones. Okay, you should now be able to do exercise 4C on pages 101 to 102. We'll just do a quick recap of this. So here we're drawing these modulus graphs. So with that type of modulus, let's say we've got this. Then we'll reflect up. If we have this type of modulus, then we would have, let's say I've got something like this, and there's the original graph, and then I'll reflect that over there like this. And on these types of questions, just watch out for the crossing points. Okay, so watch out for crossing points. You want to make sure that you include all of them. So you might want to maybe work out where the second graph crosses the axis, just to make sure that you get the crossing points in the right place and you get the right number of crossing points. And remember to ignore any solutions that you find which are actually not the crossing points that you want, that needs to answer the question. And remember your set notation, that you write something like this, and then your inequality here. And it may be that you have two of them, so then you might have union, and then you have x, and then your other inequality here.